BSc Statistics students. In this lesson, I explain one more problem on chi-square test for independence of attributes. This is also a small sample test, right? So you see the problem. Two researchers adopted different sampling techniques while investigating the same group of students at different intelligence levels. The results are given below. We see the results. Examine whether the sampling techniques adopted by the two researchers are significant. That is what you have to examine. You see, first of all, results. So these are the results by the two researchers by adopting two particular sampling techniques. Adopting different sampling techniques. You see here researcher 1, researcher 2, and these are the intelligence levels. They have taken different intelligence levels: below average, average, above average, and genius. They have taken, this is the number of different intelligence levels of the students, group of students. And these are the results down. Now it is required to examine whether the sampling techniques adopted by two researchers are significant or not, right? For which we consider it is very simple. While seeing this, we can easily identify that it is a chi-square test for independence of attributes. We can easily identify, we can easily explain, we can easily identify, right? So the first point, null hypothesis H0, there is no significant difference between two sampling techniques adopted by two researchers. There is no significance, which means they are independent. And the second one, alternative hypothesis H1, there is a significant difference between the sampling techniques adopted by two researchers. So there are dependent. All right. And the third point is test statistic under H0. In the test statistics, what you have to consider, first of all, contingency table, for which you consider the attribute A with the sampling techniques adopted by two researchers. Attribute B, intelligence levels. You see here, this is sampling techniques adopted by two researchers, 1, 2, and these are the intelligence levels, the two attributes A and B we have considered, for which we have prepared the contingency table. You see here the contingency table is nothing but A having two attributes A1, A2, B having 4 attributes, 4 classes, or we can consider class is nothing but an attribute B1, B2, B3, B4, in which you have to write the inside whatever the given frequencies, you have to write O11 observed frequency, O12, O13, O14. You note down this. That is, the given data is 84, 60, 44, 10. This is the data, the same data you furnish here, 86, 60, 44, 10. You consider this is O11, O12, O13, O14. Similarly, second one, second row, O21, O22, O23, O24, 40, 33, 25, 2. You consider which are the given observations in the data, hence we consider observed frequencies O. And against to A, if you add all these frequencies, you will get A1. That is, A1 is equal to 200, 86 plus 60 plus 44 plus 10. Against to A1, you will get frequency of A1 is equal to 200. Similarly, against to A2, you add all this, you will get A2, frequency of A2, bracketing A2, frequency of A2 is equal to 100. And similarly, B1, against to B1, frequency of B1, 86 plus 40, 126. Similarly, B2, frequency of B2, add this, you will get B3, add these two, B4, add these two. So, and finally, you add row wise or column wise, that is all A's or all B's. Summation AI, summation Bj is equal to 300. Any one, not both, any one. 200 plus 100, 300. That is Kaplan. Now you have to calculate expected frequencies. I'll tell you one or two so that you can easily understand. Expected frequencies which are denoted by EIJ. In the formula, Oij and Eij, these are the two particular important terminology terms we have. E11 formula, what is the formula? Frequency of A1 into frequency of B1 divided by N. So corresponding to O11, you will get E11. So against to that A1 200, against to that column wise you will have B1, that is 126 divided by 300, capital N. It is 84, something the value 84. You calculate the values. E12, frequency of A1, frequency of B2, I and J. It is easy to write the formula. E12, A1, B2, frequency of A1 into frequency of B2 divided by N. Frequency of A1, 200, frequency of B2, 93, divided by 300, N, capital N, 62. Like that, E13, A1, B3 divided by N. E14, E13, A1, B3 divided by N. E14, frequency of A1, frequency of B4 divided by N. Like that, you can calculate all the values. Calculate E1, E21, E22, E23, E24, etc. All the values you have calculated here. E21, 22, 23, 24. For example, E23, A2, B3 divided by N. What is A2? A2 is nothing but against to A2 here, 100. And B3 is 69. 100 into 69 divided by 300 is equal to 23. So this is the way you have to calculate all expected frequencies. How many O's are there? You have to calculate for every O, Oij, you have to calculate Eij. How many O's are there? You have to calculate the same number of E's, expected frequencies. After calculating the expected frequencies, you have to formulate a table like this. This is for calculation of chi-square. Calculation of chi-square. What you have to do? Oij, Eij. You have to write first columns, and then you have to calculate Oij minus Eij, and then you have to calculate Oij minus Eij whole square by Eij. These are the columns you are required to calculate. You see here, this is here one particular important point as well. It is called pooling technique. Or whenever the observation is less than 5, then you have to pool to the previous observation. Here in all the observations, we have less than 5 observation is this 2. This is 25, this is 2, last observation. So hence you have to pool to the previous observation, that is 25. 25 plus 2, 27. The same thing it is also to be done in the another frequency, Eij. For example, this happens in Oi, Eij, if this happens in Eij, then you have to pull the same thing in Oij. If it happens in Oij, you have to do the same thing in Eij, even though it is not less than 5. Because here we have 2 observations, then 2 observations becomes 1 observation. And obviously here also the 2 observations must be taken as 1 observation. Otherwise calculations will not run. Okay, right, I hope you understand. So here also less than 5, even then. What you can easily understand that if you have pulled here, you have to pull here also as well in Eij. In Oij you have pulled, then automatically the same corresponding observations are to be pulled in Eij. So 23 plus 4, 4 plus 20, 27. 27 minus 27, Oij, 0. Oij minus Eij, 0. 86 minus 84, 2. 60 minus 62, minus 2. Like that, you calculate all Oij minus Eij values, and then Oij minus Eij whole square divided by Eij, which means 2 whole square, 2 square divided by Eij, 84. Like all the values you calculate. And then get the total. That is double summation. I is equal to 1 to R, summation J is equal to 1 to S, Oij minus Eij whole square by Eij is equal to, if you add all these values, you will get this, 0.923. Therefore, chi-square is equal to this summation, double summation Oij minus Eij whole square by Eij, which is 0.923. This is our required test statistic under H0. And then inference or comparison and conclusion. The next point you have to consider. Like chi-square is 0.923 calculated value, and chi-square alpha comma r minus 1 into s minus 1 minus k. What is k? K is nothing but the the degrees of freedom pooled to the degrees of freedom, that is one particular frequency. How many number of frequencies are pooled to the previous one, previous observation? How many number of frequencies are pooled? Only one, that is the k is equal to 1. 2 was pooled to the previous one. The frequency 2 is pooled to the previous one. Therefore, one observation was pooled. There one frequency is pooled. Therefore, k is equal to 1, which is less than 5. That is r minus 1 into s minus 1 is 2 minus 1 into 4 minus 1 minus 1. The value is 2. 1 into 3. 3 minus 1, 2. 5. And level of significance is not given alpha. Hence, we have to consider 5%. So, 5%. Chi-square at 5% level and 2 degrees of freedom, the tabulated value or significant value from the chi-square tables is 5.99. So, if you compare these two, 0.9 is less than 5.99. Therefore, chi-square is less than chi-square 5%, 2, which implies H0 may be accepted. What is H0? There is no significance difference between the sampling techniques adopted by the two researchers. So, there is no significance difference between, they are independent, which means they are independent, they are not dependent. Whatever the sampling techniques adopted by two researchers at different levels of intelligence levels of the students, which are independent. So, that is the conclusion. There is no significance difference between the sampling techniques adopted by the two researchers. Thank you.